Hmm. Trigonometry, Chapter 2, Acute Angles and Right Triangles. Section 3, Approximations of Trig Function Values. Video 1, Finding Function Values with a Calculator. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous section, we explored trig values of non-acute angles by associating them with acute angles, in particular, reference angles. In this section, we discuss approximating values of trig functions. In this video, we explore using a calculator to obtain these approximations. In a previous video, 1.3.9, we mentioned how to use a calculator to approximate trig functions. Two specific points were: number one, make sure your calculator is in the correct angle measurement mode. For now, that mode should be degrees, and on many calculators is abbreviated DEG. Later, we will need to change that mode to radians, which is usually abbreviated RAD. And number two, the inverse trig functions, such as sine inverse of x, are not to be confused with the reciprocal functions. To evaluate something like cosecant of 10 degrees, we would enter 1 divided by sine of 10 degrees, not sine inverse of 10 degrees. For example, let's use a calculator to evaluate sine of 49 degrees in 12 minutes. To enter this in a calculator, we can convert the degree minute second measurement, abbreviated DMS, into decimal degrees, abbreviated DD. Recall that 1 minute, with a single mark, is 1/60th of a degree, and that 1 second, with 2 marks, is 1/3600th of a degree. Thus, to convert degrees, minutes, seconds to decimal degrees, we divide minutes by 60 and seconds by 3,600, then add the results to the degrees. Thus, 49 degrees in 12 minutes is equal to 49 degrees plus 12 over 60 degrees, because to convert from minutes to degrees, you divide by 60, and that adds up to exactly 49.2 degrees. Therefore, sine of 49 degrees 12 minutes is equal to sine of 49.2 degrees, which is approximately 0.75699506. Round to however many digits is requested by your teacher or by a specific homework or test problem. Now, we could have also entered the conversion from degrees, minutes to seconds to decimal degrees inside the trig function like this: sine of 49 plus 12 over 60, and gotten the answer more directly. This is actually preferable because dividing by 60 or 3600 often results in inconvenient decimals. Now, some calculators will allow you to type degrees, minutes, seconds, in which case you would just enter the problem as it was given. Check your calculator. If you see a DMS or DD, it probably lets you do that. All right, next example. Use a calculator to evaluate secant of 97.977 degrees. Well, secant is one of the reciprocal functions. It's the reciprocal of cosine. So if your calculator does not allow you to enter secant directly, because some do, you must use the reciprocal identity, secant of theta equals 1 over cosine of theta. So we would just enter 1 divided by cosine of 97.977 to get approximately 7.20587921. Of course, if your calculator has a secant option, you should use that. How about this one? Use a calculator to evaluate 1 over cotangent of 51.4283 degrees. Well, if your calculator has a cotangent button, you can use it and type this in. But this is where you should work smarter, not harder, because the reciprocal identity says that this is equal to tangent of 51.4283 degrees. Tangent and cotangent are reciprocal functions. So you could just type that in directly and get approximately 1.25394815. And one more quick example, sine of negative 246 degrees. Okay, there's no trickery to this one. You just enter it directly into your calculator to get approximately 0.91353436. But in general, when you're entering trig functions in your calculator, look to take advantage of things like reciprocal identities here and here. And if you're entering degrees, minutes, seconds, be ready to accommodate for that as well. All right, now you try. Pause the video and try the following. Use your calculator to evaluate the following, round to 4 decimals. All right, here's your fair warning if you haven't paused the video yet. Solutions in 3, 2, 1. Did you use a quotient identity on the last one? You didn't have to, but you could have.